would like to start with the program. We are very privileged to have with us Professor Tripathi online and speaker of today's monthly lecture series, Dr. Tirthankar Banerjee sir. It is a great privilege to have both of you here. I would like to start with the... Okay. अब शुरू हो रहा है क्या? नहीं. So, as you all know, the board has started a monthly scientific lecture series just to disseminate the information on environment and related subjects among students, academia, and public in general. So this is the sixth lecture in the series, and I am pleased to inform you that this is well taken and acclaimed by different sections of the society. Yesterday also we had our principal secretary with us, and he also acclaimed and praised, I should say the board for this very initiative. So slowly and slowly, this is gaining popularity among masses and the people who are related, who are concerned with the environment. So this is a step taken by board in a positive direction, and I am very pleased that today we are going to discuss about a very important topic on aerosol by Professor Tirthankar Banerjee from Institute of Environment and Sustainable Development, BHU. So before we go to the lecture, may I request Member Secretary of the Board, Sri S. Chandrasekhar ji, to just present a welcome address, sir.
Honorable Chairman, sir, Bihar State Pollution Control Board, Professor Ashok Ghosh, sir, Professor S.N. Tripathi, sir, Professor from IIT Kanpur, who has joined us virtually. Today's our guest speaker, Professor Tirthankar Banerjee, Assistant Professor from Institute of Environment and Sustainable Development, Banaras Hindu University, Varanasi. So it's our privilege to have you here today for you to deliver today's lecture as part of our monthly lecture series, scientific lecture series. This is the sixth in the series. So earlier we have discussed, we have already conducted this such sort of lecture on topics like water pollution, on construction and demolition waste, on solid waste management, and on air pollution as well, sir. So this is as explained by our senior colleague, Dr. Naveen Kumar. This is an outreach endeavor by the Bihar State Pollution Control Board to take the environment-related information among the masses and among the academia, especially related to the topic pertaining to Bihar and the issues which are affecting Bihar's environment here. So as part of that endeavor, so we have initiated a lot of other activities, among which this is one among that such activities. It's the scientific interactive series. As we move ahead, the popularity of this program is also gaining momentum and popular among the students and faculties of different educational institutions in Bihar. So, sir, once again, I take this opportunity to formally welcome you, sir. We are happy to have you here today. Also, I take this opportunity to welcome my colleagues here who have joined physically, and also I'm here that one faculty from IPCC has also joined virtually. Welcome, ma'am, to you. Also, I welcome all other guests today who have joined virtually. So, with these few words, I request our senior colleague Mr. Dr. Naveen Kumar to formally introduce our today's honorable guest speaker. Over to you, Naveen sir.
Okay, thank you, sir. Sir, before we move further in the program, we are privileged to have Dr. Tripathi with us. Or though Dr. Tripathi is traveling, I don't know whether it will be very convenient for him or not. But sir, क्या करें, मजबूरी है, आपको अपने बीच पा करके हम ये मौका छोड़ भी नहीं सकते. So may I request you, sir, to please say a few words. Dr. Tripathi, sir.
Thank you, Professor Ghosh, Chairman Board of Bihar Pollution Control Board, and Sri Chandrasekharji, Member Secretary, Dr. Saha, all other colleagues, and all the participants, ladies and gentlemen. I think it's a fantastic start on the part of Bihar Pollution Control Board. I'm truly elated, excited to see that the board has started looking into the broader sustainability goals in mind, as it was mentioned by Member Secretary, that we know that development has to happen, but we also must protect our environment, be it water, soil, or air. Particularly, I can tell few words about air, because the today's speaker is also going to speak about one of the major criterion pollutants that are particulate matter. He's going to speak about aerosols over Gangetic plain. Most of the audience would probably know that Government of India has launched a very major ambitious program, which is now into its fourth year, Clean Air Program, to with a goal to cut down particulate matter 2.5 by about 40% by year 2025 or so. And I just witnessed, in fact, Professor Ghosh was also there. We had a very nice time where a ministry selected few cities across India on a competitive basis, which are being able to cut down particulate matter in last few years by diligently implementing their action plan. So in a way, I think things are happening, things are moving in a right direction. And you also know that as part of Clean Air Program, we have a mechanism in which some knowledge transfer, knowledge sharing is happening by creation of National Knowledge Network. And under that, we have identified about 19 institutes of repute. I'm also very happy to observe in last few months during my intense interaction with the Bihar board officials and the team, that they have engaged the institutes of repute on a regular and in the state of Bihar. They also have a vision to approach and engage institutes of repute, which are located in the vicinity of Bihar, and they have an intent to engage them deeply, as I understand. This series definitely is a right step in that direction to create awareness. Probably it would also act as a baby step towards adding capacity to the existing institutes of repute. I hope that this is getting streamed, as it was mentioned. This also should be recorded and shared with all engineering colleges and universities where any type of or kind of environmental science and engineering related education or research is happening. It would have tremendous effect in coming days. And I also request Mr. Chairman that in coming days, as this series gets more momentum, we can probably pick up one of the any great it will add more gravitas to this lecture series. So with that, I will not take any further time. I'm very privileged to be part of this 6th scientific interactive series, and I wish all the success to series under the leadership of Professor Ghosh and Sri Chandrasekhar. Thank you so much.
Thank you, Dr. Tripathi. Thanks a lot. And we are looking forward for more association with you. Thanks a lot for joining us.
Thank you, sir.
Thank you so much. As you have suggested, we will definitely carry it up. Actually, we are getting it recorded and
Posted in our channel.
It is also posted on YouTube channel and different media platforms. So in coming days, we will disseminate it in other forms also. So
Which is colleges, university.
yes, colleges, universities, as you have suggested, we will be sending them directly also,
Yes.
apart from the social media platform. So thank you, sir. Thank you once again. And now I would like to request our dear colleague, board analyst Sri Arun Kumarji, to introduce Professor Tirthankar Banerjee to the audience. Sri Arunji, please.
Respected Chairman sir, MS sir, and other persons or colleagues present in the hall and attending the meeting through online system. Professor Tirthankar Banerjee is presently affiliated with Institute of Environment and Sustainable Development, Banaras Hindu University, as an assistant professor. His research is focused on geographical modeling of aerosols and trace gases, addressing uncertainty related to vertical profile of aerosol and their subtypes, aerosol transport and meteorological intervention on air quality using both ground and satellite-based aerosol database and relative algorithms. He has been a visiting researcher at Laboratoires de Physico-Chimie de Atmosphère, Dunkerque, France. He is a recipient of Green Talent Award by German Ministry of Education and Research, Associate Editor in Bulletin of Atmospheric Science and Technology, Springer, and in Frontier in Environmental Sciences. Thank you, sir.
Thank you, Arunji. I have been assigned to brief about the topic. So, sir, the topic is of great interest and is of topical interest. Even right now, some media persons are present in the office just to take feedback from our chairman and secretary, sir, on the air pollution in this region. Sir, we are blessed to have River Ganga with us. We are living on the banks of earth. It is a blessing. But at the same time, as you know, for this entire Indo-Gangetic plain, there are some geographical and climatological factors that affects our air quality. And especially during this season, it becomes a matter of concern because of the various reasons which I am sure our learned speaker of today will like to dwell upon. The air quality goes to bad, to worse, and it makes a lot of hue and cry among public. Though not, I don't know how much it affects directly, but of course it affects directly or indirectly to us. But we are placed in this Indo-Gangetic region where the wind is northwest. So that is responsible for all these reasons, and the entire air shade area of this IGP gets affected. So in this context, the discussion on aerosols and the climatology and its effects on air quality is definitely a matter of concern and of topical interest. I am sure our learned speaker today will be dwelling upon it and giving us more insight on the subject, so we can be able to face the situation more effectively. So with this introduction to the subject, now I will like to invite Professor Banerjee to present his address for the benefit of the audience who are present today or even who will listen to it afterwards. Dr. Banerjee, please.
Am I audible, sir?
Yes, sir. Yes, sir. Perfectly.
Just to share my screen. Just a second, I'm sharing my screen. Is my slide visible, sir?
Yes, sir. Yes, sir.
Okay, so first of all, thank you very much for this warm welcome and for developing the context of the discussion. As briefed earlier, I will be talking on aerosol climatology over Indo-Gangetic plain, South Asia. So this is our institute, this is BHU, and we are actually working on geospatial analysis, particularly in focusing the Indo-Gangetic plain. And we are also working on aerosol and atmospheric chemistry. More particularly, we are dedicated on understanding aerosol vertical profile and the effect of boundary layer on the aerosol profile. And also we are trying to relate the air quality with the epidemiology, like health effect and how the mortality and morbidity are related with the air pollution. So very briefly, as already been discussed, I'm just take a few seconds that what is aerosols, that any solid or liquid particles that are suspended in an atmosphere, and that system is called aerosols. What is complicating is that these aerosols are actually evolved and continuously grow. So it also transform. It has a particle or gas to particle conversion, and that's why an aerosol that is emitted from a particular area, when it transport to a larger distances, its nature, its property, both in optical and chemical property, and how it is going to affect the climate and human health gradually changes. That makes things much more complicated, because apart from the trace gases that don't have such kind of regional nature, aerosol has a very specific regional nature or signature. And that's why the heterogeneity at a spatial and temporal and vertical level are very important to understand that how aerosol is going to affect the climate and human health. Now, the most basic sources or most conventional sources of aerosols, if I call it, it's like a PM 2.5, which is a particulate matter less than 2.5 micrometer diameters, aerodynamic diameter. The major sources are like biomass burning, even from the biogenic emissions, the volcanic eruptions, forest fire, sea or marine aerosols, industrial emissions, and traffic emissions. And even apart from these, the other important sources over the Gangetic plain is the burning of waste and refuse. Typically the municipal waste, which are often discarded in the street, and to rid of, we actually just to burn them to avoid disposal. So this also causes a lot of PM 2.5 and a PM 10, which actually comes to the atmosphere, nucleate condense to form a larger particle, and either they affect the atmosphere by a direct effect or aerosol radiation interaction, or they affect climate by as an indirect effect, what we call aerosol cloud interaction. And by this, they can affect the hydrological cycle by changing the precipitation pattern, by modifying the cloud morphological property, like by extending its residence time, making more cloud which are not producing more rainfall, and thereby it affects the agriculture production, food security, and human health. So all things are actually interconnected. The kind of sources that is present in a particular area, the kind of aerosols that is generated from individual sources, and then as it goes or passes through transport from one region to other, There are changes in the physical and chemical property, and thereby its effect on aerosol cloud interactions or aerosol radiation interaction keeps on changing. So overall, like if we differentiate that is how the aerosols are affecting the climate or the global warming, there are basic differences in terms of the greenhouse gas, how the greenhouse gas is affecting the climate and how the aerosols are affecting the climate. The aerosols particularly are regional, and that is very important, and that is one of the core aspects that I'll be discussing today. The signature of the aerosols are very much regional, that it emits from a particular source, it goes to a certain distance, but when you compare it with the greenhouse gases, they can transport to a larger distance. Therefore, they induce more of a homogenic impact on the climate, which wherever the aerosols impact are more location specific or region specific, therefore they are induce heterogenic impact. So now there are many aspects to measure the aerosols, like there are, and the basic components includes inorganic species, organic species like organic aerosol, polyaromatic hydrocarbon, VOCs, elemental carbon, mineral species, which is coming from the crustal sources, and bioaerosols. There are many processes to measure this kind of composition by using ground-based monitoring system, and it just these figures indicate that the composition of the aerosols, or you can call it the composition of the PM 2.5, vastly changes as per where we are actually monitoring. Now, if you compare this again in Varanasi, which is a very closest city to the Patna and in very close to the Bihar, you will find that there are differences in the what kind of aerosols we are talking. If the aerosols are PM 2.5, which are actually larger in size, like coarse particulate, they are something more minerogenic. They have more mineral particles. They are more crustal particles. They have slightly less amount of elemental carbon and organic carbon component in compared to the finer particulates like PM 2.1 and PM 1.1 or 1. So that means we need to understand that what is the size of the particulates that is present in the atmosphere and their composition, so that we can relate these aerosols compositions and their sizes with the human health impact and the climate change impact. So that is my core aspect, that it is not only the absolute mass of the PM 2.5 is important. We have to know that what is the basic composition of the PM 2.5. Is it more of inorganic and organic aerosols, or it is having more of a crustal materials which is actually come over this tropical belt more easily because of convective movement of the wind, or it is coming from industrial sources having more amount of carbonaceous particles which are having potentially carcinogenic. That part is required to understand. Like you will find that globally there are different regions have a different signature. Like over the Middle East region, they have more of a dust aerosols, but when you compare over over the African area, we have a agriculture burning emissions of aerosols are more prominent compared to the Sahara region, where we have a dust particle, and over the North America, this is most made up of smaller fine particles coming from the either wildfire smoke or coming from the industrial or automobile emissions. But if you compare this kind of regional signature of aerosols against what is actually prevalent over the Indo-Gangetic plain or even over the Indian subcontinent, you will find that this is typically a mixed kind of aerosols. It has a numerous kind of sources coming from the biomass burning, coming from the industrial emissions, coming from the automobile emissions, and also coming from a long-range transport. That's why the aerosols that is present over this South Asia or particularly Indian subcontinent are much more complex, and their impact on the human health and the climate is much more complex compared to what we actually experience over the other geographical region. So how to measure this global distribution of the aerosols and how to measure that transport or long-range transport of aerosol from one region to other? One of the important application is the use of satellite database. Now, there are many satellites, that Indian satellites and the NASA-based satellites or JAXA satellites are there that we can use to monitor long-range transport and or to understand the system on a global basis, to understand that what is actually happening in the system, that how much aerosol is actually coming from a long-range transport, what is the optical and physical properties of this aerosol that is present in the atmosphere, and how it is actually affecting the hydrological cycle. So I'll be taking advantage of one of the important constellation of satellites that is present over the atmosphere. We call it the Earth Observation System satellites, or another important term is the afternoon constellation satellites, where we have particular satellite like OCO, GCOM, Aqua, Aura, Calypso, CloudSat. They are different kind of satellites are actually running over the same region with a very small time gap. So that leads to provide us information from different sensors, different information from a different sensor within a very small time gap. So we can actually have the complete idea that what is the nature of the aerosols and how it is actually varying over a large geographical region. So by using this kind of satellite database, we can have such kind of image that the global distribution of the aerosols in a daily basis, and also you can track their changes. Now, this is another important factor, like when we go to understand the or use the satellite database, there are many complications that need to be done. So I'll be taking just few seconds to discuss that. To understand what kind of algorithm we're actually following to retrieve aerosols from a satellite is a very important. Like you'll find that one of the most important algorithm is the MAYAC algorithm, which provides us 1 kilometer resolution data. So we can actually classify the aerosol optical property over 1 kilometer region or pixel. So this provides a very good, like over you see that on 21st December 2016, the typical smoke distribution over the entire Gangetic plain. This is the entire northern India. The one aerosol algorithm can capture this, but other algorithm may not able to properly capture. Like in the dust on the 21st April of 2010, the entire the western part and the northern region having a huge amount of dust. So one algorithm can able to catch, other algorithm cannot able to catch. So this is another important point that we need to keep in mind, that we need to choose algorithm properly to understand the episode specific event. Now, the context of today's discussion is what is actually happening over the Indo-Gangetic plain. Now you'll find this Indo-Gangetic plain spread across from the Karachi to Lahore to Delhi, Agra, Kanpur, Banaras, Lucknow, Patna, and Kolkata to Dhaka. So this entire region is actually having a similar kind of geographical nature, like a flat plain. So whatever happens in a particular area, any of the particular area, it has a chance that these aerosols or particulate matter may be transported throughout this region. So if we just subset the Gangetic plain, like this is the Gangetic plain, you will find this is the Lahore, this is Delhi, and this is the Kanpur, this is another another city, and this is the Bangladesh, Dhaka. You will find that by the selection of different algorithm provides a different kind of aerosol optical depth. Some provides more amount of aerosols presence and some amount of less amount of aerosol presence. So taking these ideas or taking this observation into context, if we compare that what is actually happening in a two important city over the Indo-Gangetic plain, you will find that on a 10 years time scale, just from 2006 to 15. Now, this is if you consider that this is a very old data, so this is simply to indicate that on a 10-year larger period, long-term period, what is the trend of aerosol optical depth or aerosol loading over two prominent cities? You will find that both in Varanasi and Patna, from 2006 to 15, there's a continuous increase in the aerosol optical depth. Obviously, there's a lot of peak and troughs, there's a lot of increase and decrease, but overall, the increase is prominent. Now, if you found that what is the interannual variation of the aerosol optical depth of a different city, you will find that the interannual increase in the AOD in Patna is almost 42%. So that means in each year, the AOD is slightly increasing, and which is the similar trend that is found in also in Varanasi, but not in that extent over the Lahore and even the Delhi and even in the Kanpur. So what is actually happening over this region, over the Varanasi, Patna, or you can say the lower Gangetic plain, that why the aerosol optical depth is actually increasing with the years, which is not so prominent over the Delhi and Kanpur region. Now, this is the core of this discussion, that actually aerosol transport, and that's the long range transport from a larger distances, induce, or you can say it brings come along with a lot of pollutant from a different vertical height, from the northern plains and from the western region of the India, and even from the farthest Middle East region, that actually keep on accumulating aerosols over this particular region. Now, obviously, the wind movement at a different vertical height is very much different. Now, you'll find that some of the wind, which are actually coming at a near about 700 millibars. So, as you go in the upper atmosphere, the wind pressure will decrease. So you'll find that at the upper atmosphere, at about 700 millibar pressure, you'll find that the wind is actually coming from the totally from western region. And when you go to the lower surface at about the wind vector at about 925 millibar, the wind is actually coming from mostly from the northern region. So both these wind that is coming, like in January, there's a slight change during this during the February, and almost similar during March. So these three typical months, you will find that the wind is actually coming from the northwesterly direction, but also that varies with the height. Some is at a higher height is more prominent from the westerly, and at a lower height it is coming more prominently from the northern side. So both these kind of varying wind on their movement can actually come along with a different kind of pollutant, and you will find that due to this movement of the this wind, you will find that the red lines indicate, or red zone indicates the higher aerosol optical depth, whereas the blue one indicates a lower optical depth. You will find that typically during January, there's a more accumulation of the aerosols over this lower Gangetic plain, which is actually the result of long range transport and also coming from the ground sources. Now, there are typical examples that how the wind actually bring a lot of dust particles from the Middle East. This clearly indicates that the dust particles originating from the Middle East is actually transported towards the western regions of the India. Now, that another important factor, why this wind is actually coming towards the central or lower Gangetic plain, not in the other place. Now, this is actually purely a meteorological factor, and which we cannot change actually, because this happens over a large geographical region. Now, if you find this, the first figure, it indicates different isobar, that how the wind pressure is varying with the distances. You will find that there is a high pressure zone over that is coinciding with this lower Gangetic plain, particularly over the Indian state of Bihar, lower West Bengal, and some part of the Jharkhand. So what happens? There's a consistent anticyclonic zone that creates over this particular region. So this anticyclonic zone, that means the higher pressure zone, is the nature of this higher pressure zone is actually the accumulation of the aerosols. That means these anticyclonic zones act as a subsidence zone. That means the wind, which is coming from a long range distance or the transboundary movement, they come at a higher height, and due to formation of this anticyclonic zone at a higher height, the wind subside over this region, over this lower Gangetic plain. As the wind subside, so typically wind, which is actually burdened with a lot of pollutant like aerosols and other trace gases, they inevitably coming and subside over this region and increase the pollution load. So that means even we do not have a significant contribution from the local air pollution sources over this region, still wind will bring many air pollutant from the upper northern region, or you can call it from the northern Indian part, or where the Delhi and other regions, and it will bring those pollutant over the Bihar, Jharkhand and West Bengal, and keep on accumulating the pollutants. Like you will find that the dust particles, this is typically during the month of the January and December, this gray color, this is indicated the presence of the dust and the smoke. They actually coming towards this is the white lines indicate the Banaras city, and the Patna is very nearby. So grease on gradually come and accumulate. Now the third figure also indicate that movement of the wind and also the accumulation of the aerosol, like the aerosol optical depth. Typically more or red in color indicates the greater in quantity. So again, you will find that due to presence of the higher wind speed, also presence of anticyclonic zone over this region, the pollutant keep on accumulating over this region, and they actually persist for a longer time. Their residence time gradually increases. So that leads to more or higher concentration of the aerosols over these regions, which is typically, I'm not saying that the local sources do not contribute, but I'm saying that, but I'm insisting that the meteorology drives this pollution over this region and keep on accumulating pollution over this region. So this is not a phenomenon over this Gangetic plain only. This happens over many global area. Like you'll find that the Australian bushfire that happens in December 2006, and then 14 December, when the pollution start, it actually move on and move along the entire northern hemisphere in 18 December, 19 December, and as they move the entire southern hemisphere, they reach over the Australia again during the 24th December. So it took only 10 days to transport this dust or smoke pollution from the Australian bushfire to come back to Australia. So by 10 days, the aerosols actually move the entire globe to come back to Australia. So it happens globally. Now you'll find that this is also happens over the other global geographical region, that wind actually transport over different region. Like you'll find that over the African belt, the pollution is actually transported, like the Saharan dust, they actually transport the entire Pacific and they come to the American region. Even the pollutions which is coming from the China, they transport to a larger distances. So it's a global phenomenon point. Now, if we compare that two important short-term event, like the biomass burning event over the Punjab and Haryana, and their implications over in the lower Gangetic plain, typically the biomass burning event happens in a two-time period. One during the October-November, when the rice residues are harvested and land are being cleaned for making way of wheat transplantation. And also during April-May, when wheat are harvested so that next crop can be shown. During both periods, during October-November and during May, both periods there's a burning of the rice and of wheat residues. But typically, more burning happen, like you will find the fire count, more burning happens during October and November. This is the burning or fire count in a different year. But during April-May, the fire counts are still less in number. But again, the meteorological situation over these two periods are quite distinct. Like during October-November, starting from the October-November, the winter is generally onset over the northern India. These changes in the wind and these changes in the boundary layer configuration that actually act as a lead over the atmosphere. And this formation of the lower, or you can call it like a reducing the depth of the boundary layer during the October, November and December actually help to pollutant to get accumulated over this region. Now, if you compare, this is how the biomass burning is actually induce many pollutants over the region. Like you'll find that over the Punjab and Haryana belt, there's a lot of biomass burning fire. This red dot indicates the small scale fire event over this particular region. Now, if you relate that how the pollution is actually transported, you'll find that this same region is actually having a huge amount of smoke. This gray color indicate the presence of smoke. So this is actually coincide over where the burning is actually happening over the Punjab and Haryana region and over the Pakistan regions also. And there is a great accumulation of the smoke. And these smoke particles are gradually what will happen, these smoke particles are actually transported by the westerly wind from this northern India and typically from the upper Gangetic plain towards the lower Gangetic plain. And due to, as I discussed earlier, due to the formation of the anticyclonic zone, typically during the winter and post-monsoon to winter, they keep on accumulating these smoke particles over this region. That is gradually increase the concentration of the aerosols, concentration of the both fine and coarse particulates. Now, there's another important factor that we need to keep in our mind, that this movement of the wind is not homogeneous. Like there are different in the vector wind in a different height. At some particular height, the wind is more of a westerly in nature, but at a higher height, wind is more typically from the northern region, northerly. So that means both height, the pollution that is actually coming towards the lower Gangetic plains can be much more different. So if we compare, like these two figures indicate that what is actually happening during the peak biomass dominating period over the Gangetic plain compared to the area or period when the biomass burning period was not so severe. Now, if we compare, like this is the biomass dominating period. The biomass dominating period means typically you can consider from the mid of October to end of November, when we actually experience the highest burning activity over the northern India and accumulation of the pollutant. And rest of the period, like biomass least dominating period, that is the first 15 days of the October, when the pollutions when the burning just started over the Punjab and Haryana and this region, but they do not coming towards the lower Gangetic plain, and the rest December part, which is typically a winter month, but do not have a significant contribution from the agriculture residue burning. Now, we have compared using different satellite data like the aerosol optical depth from the MODIS. We have used the Armstrong exponent. This Armstrong exponent indicate what is the nature of the aerosol. These aerosols are fine or coarse, or there are mixed kind of aerosols. More fine aerosol means there are more or PM 2.5 kind of particulates. And the smaller amount of AE, that means lower than the 0.7, indicate the aerosols are mostly coarser. Now, the UVAI is a very important parameter that indicates the absorbing potential of the particulates. Like typically, if you compare this with the ground-based monitoring database, like the PM 2.5, one of the important component of the PM 2.5 is the elemental carbon, or we call this the black carbon. This black carbon can absorb the UV radiation, particularly at 880 nanometer. And by absorbing this UV radiation, they can actually increase the atmospheric temperature. So if we can have the data that what is the absorbing potential, or you can call it the UV absorption potential of the aerosols, if you can we can have the data, we can have an idea that if certain aerosols which are having higher UVAI, or that means higher potential to absorb radiation, then the atmosphere will be more warmer compared to same aerosol mass but having lower amount of UVAI. That means we will not get difference in PM 2.5 mass in the surface, but their nature is actually changing. Some aerosols are more absorbing of UV, some aerosols are less absorbing. So when the aerosol are more absorbing, they will imply greater warming over the region compared to the aerosols which are more of a scattering in nature. Now, this is the comparison of the carbon monoxide over these two particular period. And the last one is the nitrogen dioxide. On all the database is actually coming from the global satellite measurement. Now you'll find that during the both AOD, the dominating period and least dominating period, there's a hardly any variation over this particular region, that at least both time the AOD is significantly high over the lower Gangetic plain, which is over the Jharkhand, Bihar and West Bengal part. And it is also true during the later period, like in December and early October, that of course the AOD is obviously high over this region. So there is no much change in aerosol optical depth. Even the aerosol type, that is the what kind of aerosols are prominent, they're also similar. That's in the both time, the aerosols are typically fine particulates. Like that means there are more PM 2.5 particulates in the atmosphere compared to them, and coarser particulates are much more less. But which is more drastically different, that is the UVI. You will find that during the typical biomass dominating period, like starting from the mid-October to end of November, these aerosols are typically more of a absorbing in nature. And these absorbing aerosols are particularly coming from the biomass burning activity, or you can call it agriculture residue burning activity, which is spread across the Gangetic plain from the northern India till the Bihar state almost. But this absorption potential of the aerosol significantly decreased during the later period, like in winter or in the early October, when there's a less intrusion of the biomass burning aerosol. So that means the change is temporal. With the time, there is a significant change of the aerosol property over this Gangetic plain. Same thing happens over the carbon monoxide also. Carbon monoxide concentration is extremely high over this part of the entire Indo-Gangetic plain over the typical biomass burning period, and during a less dominating period, the carbon monoxide concentration is also much more declined in nature. And the nitrogen dioxide, you will find that this is hardly any difference in the nitrogen dioxide concentration, which is typically indicate the major cities where the NO2 concentration, and also the Renukut industrial belt, where the nitrogen dioxide concentration is significantly high, like in Delhi, like in other northern states. But this do not have a typical regional signature. But which is more prominent, that during this period, aerosols optical depth, that means the presence of aerosol is much more high over the lower Gangetic plain, which are mostly fine particulates and also which are mostly absorbing in nature. That means in a typical ground-based monitoring database, we can call that presence of fine particulates of having more amount of black carbon or elemental carbon is highly prevalent during this period compared to the or you can call it during the October, December and early October. Now, this figure indicate that how is actually the pollution is transported during this typical period. Now, over the years, like if you follow that during summer, what is the wind, how the wind is actually moving, and how the wind is actually moving in a different vertical height. During summer, during typical monsoon and typical winter period, all is actually in reference to the city of Varanasi, which is very much close to the city of Patna. So whatever we are having here in the Varanasi will be almost similar to the city of Patna. So we'll find that during the lower the pollution, which is actually coming at a lower height, around 500 meter, the pollution is typically coming from the upper Gangetic plain, or you can call it northern India. But at the higher height, at about 1,500 meter, it is coming from the farther distances. Now, during monsoon, both the northeast and northeast wind is actually coming. This is the typical monsoon movement. And again, during winter, all of the air mass is actually coming from the western region, or you can call it the northern Indian part, both at a lower surface at about 300 meter and also at a 500 meter. So that means this wind is actually coming from the northwestern region of the Indian subcontinent, and as the wind is actually coming from there, they keep on accumulating aerosols over the region. Like if you compare this thing again, during post-monsoon, these red dot lines indicate they are the burning activities during the October-November. During typically October-November, what are the burning and what are the fire spot over the South India? And if we plot the movement of the wind during that particular period, you will find that the entire movement of the wind coincide over the fire spot. So of course, if there's something is burning over this region, that will eventually come to the lower Gangetic plain, and as it is coming to the lower Gangetic plain, they will gradually accumulate due to the presence of anticyclonic zone. Now this figure C is a very interesting figure. You will find that we have compared during monsoon period in 2009, 10, and 11. We compared during monsoon season what is the changes in the black carbon concentration and how these changes in the black carbon concentration relate with the movement of the wind. You will find that during the low black carbon concentration over the Varanasi, during 3 typical years, now you'll find there's no differences in each year. In 3 typical 9, 10, and 11, the wind is always coming from this region when the BC concentration is very low during the monsoon period. But when we compare the BC concentration at the higher level, like at about 15 microgram per meter cube or 12 microgram per meter cube, at that time, there's a significant contribution of the northwesterly wind, which is coming towards the Varanasi. So that means the higher BC concentration is actually coming from the upper IGP and the northwestern dry region, which is actually increasing the black carbon concentration over this particular part. That simply indicate the long-range transport of pollutant from the northwesterly due to the prevalent meteorological condition is very, very important factor in accumulating pollutions over this region. So, of course, there are contribution which is coming from the local sources, and also there are contribution of the meteorological factor. Now, these figures indicate again the same thing that I'll be emphasizing, that this small red dot indicate the fire activity, particularly in one day, 8 November 2018. And this green line indicates the city of Delhi, the Delhi boundary. You will find that this is a huge amount of burning over this northwestern part. And if we compare, these red lines indicate the PM 2.5 modeled by artificial intelligence from the Maya aerosol optical depth. Now, when we plot this modeled PM 2.5 over this line indicates the Gangetic plain, Indo-Gangetic plain. So when you plot this thing, you'll find that wherever the burning is there, like typically this on the region, there's a high intensity of the PM 2.5, which is completely overlapping over the city of Delhi. And this blue line indicates how the wind is actually moving. So this is a straightforward example that yes, the pollution which is originating over this region is accumulating the pollutant, transporting the pollutant towards the lower Gangetic plain and the central Gangetic plain cities, and they are keep on increasing the concentration. Now, another important thing that will be the last part of my discussion is the vertical stratification. Like as I said, there are different wind speed at a different height. So that means there are chances that different kind of particulates can be accumulated over a different vertical height. Now, first, if you follow this figure, over this Gangetic plain, this is a typical, like this is a latitude, longitude, you'll find that over the entire Gangetic plain, there is a dominance of this orange color. And this is coming from the Calypso satellite, which is a vertical leader, and is a very, very important satellite, which provide the vertical distribution of the aerosols. That means in each 30-meter height from the surface to a certain height, and then up to 60-meter resolution, they provide that what is the aerosol, how much the aerosol is present, and what is the type of the aerosols is present there. You will find that up to 0 kilometer to 5 kilometer height, there's a complete dominance of the this orange color, which is number 3, that indicate the aerosols. That means there is a presence of the aerosols from the 0 to at most 5 kilometer height over this entire Gangetic plain. Now, if you segregate that what is the aerosol type, then you will find that again, this is the same region what we are talking about. You will find that mostly the aerosols at a lower height from 0 to 3 kilometer. This is mostly of the red. This is been plotted by using MATLAB software from by using the Calypso database. You will find that up to from the 0 to 3 kilometer, mostly the aerosols are red and black in color, which indicate polluted continental, that means the urban aerosols coming from the urban sources, and also the smoke particles, which is typically from the anthropogenic activities like the automobile emissions, industrial emissions, biomass burning, and the waste burning emissions. But which is very, very significant, that you will find that from the 4 kilometer to up to 5 or 6 kilometer, there's a dominance of the dust particles. So there are aerosols from 0 to 5 or 6 kilometer, but their nature is actually changing with the vertical height. That means they have a different implication on the formation of the cloud and the atmospheric heating or modulating the oscillative power of the atmosphere. These aerosols, which are red and black in color, are more absorbing in nature compared to the dust. Dust can have an impact on the formation of the cloud because this is a zone where the cloud formation actually happens. So that means this is a very interesting point, that aerosols keep on accumulating over the Gangetic plain, but their height and their variation with respect to height is significantly differ. Now, if you compare this line bar diagram at different prominent city over the Gangetic plain, like Karachi, Multan, and all the city, if you compare Patna with the city of Varanasi, you will find that during different period, over annually, almost 60% of the aerosol over the entire atmosphere, if you use the satellite data, the entire atmospheric column, whatever the aerosols are present, 60% of that aerosols are present at a lower vertical height. The rest is present at about 1 to 2 kilometer, 2 to 3 kilometer. But that actually vary from the cities which are not in the Indo-Gangetic plain. They will find that the Kathmandu, Nagpur, they have overall similar kind of distribution with the increasing height. But these things also change. Like you'll find during March, April, May, only 30% of the aerosol that is present at a lower height, lower than the 1 km. But when you go in the October, November, and December, January, February, post-monsoon and winter, most of the aerosols present at a lower vertical height. That means they have a far greater potential to affect human body, human exposure. So that means overall we can assume that we can quantify actually that almost 1% of the aerosols that are present, 41% of the aerosol about the entire atmosphere present within the boundary layer, and almost 60% present at the above the boundary layer. But this is not universal. This is keep on changing based on the season, based on the certain small scale episode, based on the how the boundary layer is actually varying over a particular region. But overall, my submission is that the aerosols which are present over the Gangetic plain, they are vertically stratified, which is more prominent for different aerosol type. Some of the aerosol type, like absorbing aerosols, are more prominent at a lower atmosphere, which are having more negative human health impact. And some of the aerosols, like typically dust particle, they are present at a very high altitude from 4 to 6 kilometers, and they imply on the formation of the cloud. And accumulation of these aerosols at a different vertical height is the effect of ongoing or moving wind at a different vertical height. Now, another important example by which after this I will end my discussion, that what is happening during the Diwali festival, a very small scale event, like during a single day high intensive firecrackers activity, and you will find that pre-Diwali days in 2014, before the Diwali, there are aerosols. This indicates the presence of the aerosols over the entire Indian subcontinent. But these aerosols are not having high amount of absorbing power. But if you compare this thing, after the post-Diwali, the aerosols are highly absorbing. And there are many evidence, particularly from the eccentricity groups and Chandan Sarangian and many researchers, then they simply identify that the presence of these absorbing aerosols have a marked impact on the hydrological cycle, particularly the Indian monsoon. How they imply the Indian monsoon as a very important factor, because this absorbing aerosol affect the formation of the cloud morphological property, and thereafter the precipitation level. So that will be the last slide. That again, I'm emphasizing that how the aerosol type and their properties changes with this very, very small scale event, like in Diwali. You will find that Diwali during 2014, 23rd October, The aerosols which are present over the Gangetic plain, like this line indicate the city of Varanasi in terms of latitude, longitude. You will find that before the Diwali, aerosols are typically dust particles, some are the smoke, some are the urban aerosols. But after the Diwali, most of the aerosols from 0 to 3 kilometer height, most of the aerosols are particularly presence of the urban aerosols, which is coming from the urban anthropogenic sources. They are also smoke aerosols. And then as the aerosols coming from the upper Gangetic plain after the Diwali, as they are coming and transported, you will find that the vertical height is actually increased. Diwali, they are only from 0 to at most 3 kilometers. But after the Diwali, it is actually increased over this region from 0 to almost 5 kilometers, and totally by the black color, that means they are totally presence of the smoke particles, which means the presence of black carbon aerosols. And when we go after the certain days, after 26th in the first week of November, you will find that this pollution is actually removed from the atmosphere. And again, whatever the presence in the atmosphere over the region are again the dust particles and some of the particles which are the urban aerosols coming from the urban activities like the commercial activities, residential cooking and heating, and also the coming from the automobile emissions. So this small scale event also changes the vertical nature of the aerosols and the prevailing atmospheric circulation and the prevalence of the anticyclonic zone over these regions regulate the aerosol climatology over this region. So by this word, I will end my lecture, and thank you very much again for giving me this opportunity for presenting my research, and to emphasize that how the meteorology and the air pollution sources regulate the level of pollution over this Gangetic plain. Thank you very much.
Thank you, sir, for this detailed presentation and having a great insight over the subject of the meteorology of the IGP and the chemistry of aerosols and all.
इसको आउट कर दीजिए जिससे उनको देख सके हम लोग. Thank you.
So
स्लाइड उनको बोलो ये कर देंगे.
so let us give a big hand to Dr. Banerjee.
Thank you very much.
Yes, very nice presentation. And I would like to open the floor for the audience. The participants, our young colleagues who have joined offline or maybe online, they may have some queries. You are, oh, sir. I'm sorry, sir.
Thank you, Dr. Banerjee. It was a wonderful lecture that we heard. I appreciate the work that you have done. And rather, you have supported our hypothesis well on 3 counts that we often discuss with Sahaji and Tirthankar. One, that if central Bihar, Indo-Gangetic plain, is highly polluted, we are not the only culprits. There are other culprits. That is one thing.
Yeah.
Second, the PM 2.5, only size is not important. The chemistry is also important. The third thing about the vertical heights, the difference in the different level of heights from ground level. So that is major takeaway. Now, my question to you as a scientist is there, that right now, if you calculate AQI, the weightage to 2.5 is given on the basis of only size. So is it scientifically correct that the weightage for 2.5 should be given only based on their size, not on chemistry? Because in our area, the maximum pollutant that we are facing for high AQI is PM 2.5 and PM 10. Other parameters are under control. And there is havoc everywhere, that AQI is 400, 300 like that. And we understand that chemistry matters in the health aspect. It is not only the size, but the chemistry is also important. You cannot say that the PM 2.5 coming from a vehicle and coming from an agricultural field will have the same impact on the human health. So I seek your opinion as a scientist. You have worked a wonderful thing. That is it correct to give the weightage only based on the size that we are doing right now?
It's a very pertinent question, sir, and I completely agree with your opinion that only based on the PM 2.5 mass, the air quality index do not provide the accurate value. But we have to also consider the cost and operational maintenance of the air quality monitoring stations, because if you go for the measurement and then the composition of the air PM 2.5, it induces many costs, it will increase the intensive cost. So if you found that before 10 years back, we do not have the PM 2.5 monitoring stations all over India. Hardly any stations are monitoring PM 2.5, hardly before 10 years back. At that time, we were only talking about PM10. Now things change, we are talking about PM 2.5. So I believe that the things will change. We'll come to that how much proportion of the PM 2.5, at least we should know how much proportion of the PM 2.5 is made of elemental carbon like black carbon and organic carbon, and how much is the crustal composition. So this thing will change, but it requires a lot of funding, a lot of characterization simultaneously over the many cities.
Yeah, I have a supplementary.
Sir.
Of course, sensors are very costly. And if you add the qualitative analysis, that will be very, very costly.
Yes.
We can analyze chemistry through ordinary high volume sampler, the filter papers, and we can go for chemical analysis. That what are the contents in that dust particle accumulated in the filter. And on that basis, we have some idea. It won't be as sensitive as sensor, but at least we'll have an idea that what is the difference in the PM 2.5 in Kanpur versus Patna. Because
Yes.
Kanpur is having lots of industry and Patna is less. But we give the weightage, the same weightage to PM 2.5 of Kanpur and Patna. So my request to all the scientists are there that we have to raise this issue.
Yes.
Because otherwise the Indo-Gangetic plain will be always polluted.
Yes.
Whatever you do, whatever efforts you do, action plan and everything, you cannot eliminate dust. You
Yes.
cannot eliminate 2.5.
Yes.
Banerjee?
Yes, sir. I'm audible.
Oh, you are not good. So,
Yes.
so that is my request to every scientist who is working in this field, that raise this issue, because I had raised this issue in Gujarat, in Kevadia also, when I went for minister's conference. And then at that time, people said that, well, that is true, but it will be very difficult to change the standards and the measurement and everything. Lots of studies required. So nobody is ready to initiate it. So as a scientific community, you are a part of scientific community. I am also a small part. But then this is a thing that haunts me, that we are culprits without any reason. We are culprits without any specific reason. Two things, two counts. One count is that they are getting the input of pollutants from neighbors.
Yes.
And the other, our chemistry is less harmful as compared to others.
Yes,
But
sir.
we are branded as highly polluted, and others are branded as less polluted. So
Yes.
that is not fair. मेरा खून खून आपका पानी, मेरा नहीं आपका खून खून मेरा पानी, वो like dialect था ना?
Yes, sir.
तो एक बोलता हूँ, यार मेरा भी खून है, आपका भी खून है. ऐसा नहीं है कि आपका खून है, मेरा पानी है. तो इम्पैक्ट तो होएगा, लेकिन इम्पैक्ट बराबर कैसे हो सकता है? तो केमिस्ट्री अगर आप देखते हैं तो.
Yes, sir.
So, of course, this issue has to be raised on different platforms. And you are the very right person to raise this issue. Why not you write a paper on this?
Yes, sir. There are some works, sir. Actually, Professor Sagnik, they are actually doing many research on that how the different composition of the PM 2.5 are related with the human health.
Yes.
And there are some good papers globally. They indicate the presence of black carbon and the nitrate. They are
Yes.
the most important culprit compared to the PM 2.5 mass. So
Yeah.
things are changing, sir, but it will, as you said, it will take some time. It will,
Yeah.
but absolutely this is important. The composition is important rather than the mass.
ये तो आजादी तो एक दिन में नहीं मिला था ना.
Sir.
1947 में आजादी का लड़ाई शुरू नहीं हुआ था, बहुत पहले हुआ था.
Yes, sir.
आर्सेनिक में भी हम बहुत फाइट किए हैं. आर्सेनिक में पहले इंडिया में था कि 50 माइक्रोग्राम पर लीटर परमिसिबल लिमिट होगा, और WHO का बोल रहा था कि 10 होगा, और US बोलता था कि 5 होएगा. तो हम भी उसमें भी यही बोलते थे कि मेरा आपका खून खून है, मेरा खून पानी. और लड़ते लड़ते मैंने इंडिया में उसको 10 पर करवा दिया है, 10 माइक्रोग्राम. और हार के अब उन्होंने एक बीच का समझौता किया. एक permissible limit, एक acceptable limit. ये भी अभी इसका लड़ाई मेरा चल रहा है. What is acceptable limit and permissible? Acceptable 10 होगा, permissible 50 होगा. So there is ambiguity. There's no clear-cut direction. So that has to be there. That if a European can have a health issue by drinking water with 10 microgram per liter, do you expect that Indians will have the impact after 50 microgram per liter?
No.
They have also 46 chromosome and we also have 46 chromosome.
Yes.
Genetically, there may be minor differences, but human chromosomes are, the human genome is almost identical with minor differences here and there.
Yes.
So whenever the standard is met, you say that I cannot afford. Well, you cannot afford, but at least let the people know that this is harmful for your health. If you can manage yourself, that is good. If you cannot manage, then go and die. But by hiding the facts, you are not eliminating the problem. So we have to be transparent. That okay, 10 microgram and above is harmful for you. We cannot give you supply of pure drinking water at this level. Beyond 50, we are trying to give you more funding in that. In the meantime, if you want, you can go for safe water at your cost. Yes, advisory तो दे सकते हैं हम लोग, वो भी नहीं देते हैं, बोल देते हैं कि नहीं 50 microgram वाला ठीक है. And there is huge research that indicates that even 20 microgram per liter or 30 microgram per liter is carcinogenic in long-term ingestion. I'm not talking hypothetically. There are published papers on that.
These are facts.
The same thing that we have to start the struggle and come down to some logical end to this issue. Otherwise, Bihar will be always branded as highly polluted districts, highly polluted cities. We cannot do. I know we are taking many steps, but ultimately, until and unless this issue is not resolved, we will be branded as a highly polluted city.
Yes.
Yeah. Thank you very much. We'll be in touch, and if you have some papers related to this, share with Dr. Saha. I like to read it, although I get less time nowadays to read. More time I do in the file, but still I like reading. So if you send some papers, it will be wonderful. Thank you very much.
Thank you, sir.
Tirthankar, खूब दारुण lecture. Once again, clap for you. The thing is that should we not request CPCB or the ministry to incorporate black carbon as one of these parameter in our standard, so that the State Pollution Control Board can go ahead with the installation of the BC measurement across the country.
CPCB refused.
But the thing is that until and unless we do, at least we'll be lagging behind. Since the black carbon is such an important part in deciding factor, whether it is the toxic or whether it has an impact on the climate, plus driving force for pressure and light absorption, heat transfer. So all these things are required to be taken care at this moment. This is also one of the submission. Just a suggestion. Number two is that, don't you think there is a back pressure from the Bay of Bengal also creating some problem?
That actually I did not monitor yet now. What this can be true, particularly during monsoon period. During monsoon period, that can be particularly true, that the movement of the wind actually changes. But the changes in the pressure level during the Bay of Bengal, I did not actually explore that part.
So whenever I was in Calcutta, I used to feel now the tide is coming up. So Ganga will be flooded. So that impact also must be, because the Indo-Gangetic plain is a complete high pressure zone to low pressure zone.
Yes.
And once you are keeping a pressure, back pressure from the Bay of Bengal, it will have some impact.
Definitely.
And may increase your anticyclonic movement. And that may be the cause, one of the cause of accumulation of pollutants over Bihar. My observation.
I will explore.
Okay. Then number three, just I will not disturb you. Don't you think the position of the Bihar geographically is also a constraint? Because it is very near to Nepal and there is a notch, and where the pollutants are not able to move further.
Yes. So that is actually intensifying the formation of the anticyclonic zone due to the presence of the Himalaya and Nepal and this region. So, of course, the geographical situation of the Bihar, and also not only the Bihar, the the Gangetic plain of the West Bengal and the Jharkhand. So their presence over this particular region actually coincide with the formation of the anticyclonic zone. So of course, these things is a geographic, more in of a geography compared to the more of a pollution context.
Exactly. Thank you so much. Any questions, sir? Oh, floor is open for discussion, please. Floor is open for discussion.
Dr. Banerjee, I have a question. Rather, it's a notion in my mind for quite some time. This is my second stint here in the Pollution Control Board. Since the time I got posted in the Pollution Board in 2016, I had a notion that the particulate, yes, there are various sources for particulate matter, the aerosols. But in my opinion, what I had in my mind, still I'm having this doubt. It has to be confirmed by some experts like you or someone else also. That the Indo-Gangetic plain is characterized by the alluvial soil. It is a lightweight soil, less bulk density. So, so far I haven't came across any of the research paper or any discourse on this particularly, whether how much the soil particles are contributing to the aerosols.
So you are talking about
reflections.
Please continue. Yeah. Please continue.
Your reflections on this. Is that notion right, or am I that's a wrong notion?
Actually, it's completely true that if you we have characterized the sources of three different type of particulates. One is PM1, which is submicron. One is PM 2.1, which is considered as fine particulates. 2.1 because we have instrument kind of that, and the PM greater than 2.1. And we found that a significant proportion of the PM 2.1 is contributed by the crustal resuspension. That means the crustal particles which is resuspended by the wind itself. The being a tropical region, due to the less humidity during summer period, these dust particles resuspended in the atmosphere, and they quantify or they provide a certain huge amount of mass of the PM 2.5 load. So of course, this is absolutely true. There are papers, sir. There are papers that actually indicate that this alluvial soil keep on resuspending in the atmosphere. They actually transport to a larger height, and thereby their residence time also increase. They do not subside quickly due to this tropical movement, due to the convective movement. So there are some material. Yes, of course.
Thank you, Dr. Banerjee. Please do share that those research articles to Dr. Saha. I'll also go through that.
Sure.
Dr.
Actually, why this came to my mind is that when we progress towards the southern part of Bihar, slowly the PM 2.5 or the PM concentration goes down, reduces gradually. So, and in Bihar, 98% of the entire state is under the new alluvium. The rest too is older alluvium. This is locked between Himalayas on one side and Chota Nagpur Plateau on the other side. So that's why Dr. Saha has also rightly put it that is that geographical location of Bihar is at a disadvantage that which makes it more polluted as far as the definition of CPCB or WHO is concerned.
Yes, that was the point, that due to the location of the state and due to the formation of the anticyclone and subsidence, and as the subsidence generally happens for a longer period. The anticyclonic persists for a larger period compared to the cyclonic zone. So that's why the pollutant which is actually suspended, like typically the aerosols, they keep on their residence time actually increases due to this anticyclonic nature.
Okay.
So of course the geographical location of the state is an important factor.
Thank you so much for clarifying this. This will help us a lot. Otherwise,
it's a fact.
Shooting arrow in the dark. So you have given a clear picture about this. Thank you.
So we have brought you on right time, right season also.
From the very beginning,
politicians and other press people also, so that do not create any hue and cry in the society. And
actually, the regions suffer. whatever the situation, the region actually suffer.
Region suffers.
Yes,
Of
yes.
course, there are opportunities to reduce the dust level at the ground. Anthropogenic activities can be regulated to control the dust pollution from the ground level. Yes, that is accepted. Though a lot of things have to be done to control that one. But still, being in our location is such a way that it's making us more dusty. This is what we keep on used to say, that we are not polluted, we are dusty.
Yes.
Yes, yes, of course.
So
Yes.
otherwise, we are fulfilling the as far as the gaseous pollutants are concerned, we are achieving the standards.
Yeah.
Our air quality is achieving the standard. So really great.
Great. Dr. Kriparam, are you there still? Dr. Kriparam, your colleague also. He's
Yes,
joined.
yes.
The same department,
Yeah,
Dr.
same institute, yes.
same institute. Dr. Kripa is there.
Yeah, he is there.
Yeah.
You must be muted, keeper.
Oh, he may be muted, but he has to
Your mic is muted, Dr. Kriparam. Yeah. I think he's saying something.
Hello?
Yes, we cannot hear you, Kripa.
Dr. Kriparam, your mic is muted. Please unmute yourself. Yeah. That's all.
Some problem is there. Anyway,
Okay.
we have Dr. Banerjee. I mean, by name I call you, by virtue of my age. But thank you very much. But another aspect is we are going to take up a study on the source apportionment and everything. What our member secretary has suggested. We should know the geogenic, the local dust profile, and the carbonaceous profile every month. So that we will be at least able to know what is the likely contribution in different months of the year. So 2-time study, only summer and winter is not going to resolve the issue. So monthly variation of and composition would be very much important. And accordingly, we are going ahead so that we will have a clear-cut understanding of the geogenic sources plus and transported sources plus the anthropogenic sources. This is because I keep on talking to you young guys and scientists and pathfinder. So I take this opportunity to discuss with people. Thank you so much for giving me the opportunity to discuss.
Yeah, any questions from the audience here? Murthy? Papu? Any? No. Okay. So
may I request our member secretary, sir, to announce for the next lecture.
Sir will discuss.
yeah.
And propose a vote of thanks.
Our seventh lecture among the continuation of the lecture series. Our seventh lecture would be on. Yeah. Excuse me. Yeah. हाँ जी प्लीज आप इतना देर बोले नहीं थे इसलिए हम
माइक ऑन कर दीजिए आप
इसलिए तो बोले
पहले तो मिस्टर बनर्जी बहुत बहुत बधाई। मैं अंग्रेजी भूल गया हूँ इसलिए हिंदी थोड़ा सा समझ लो। मैं पोल्यूशन कंट्रोल बोर्ड के आधारशिला रखने वाला आदमी हूँ, डॉक्टर मेहता नगेंद्र सिंह। पहले एक छोटी सी बिहारी प्रश्न है कि एरोसॉल और ह्यूमिडिटी का क्या डायरेक्ट रिलेशन है?
Aerosol and sorry sir?
ह्यूमिडिटी।
Yes sir.
जनरल पीपल के लिए इट इज एसेंशियल।
सर रिलेशन इन ए सेंस मैं ये बोलना चाहूंगा, जो अगर ह्यूमिडिटी ज्यादा हो तो मोस्ट ऑफ द एरोसॉल जो होता है वो जनरली वाटर को एब्जॉर्ब करता है। सो अगर ह्यूमिडिटी ज्यादा हो तो एरोसॉल इस ह्यूमिडिटी को एब्जॉर्ब करके उसका साइज बढ़ जाता है। तो इसीलिए ऐसा सिचुएशन हो सकता है जो स्मॉल पार्टिकुलेट्स लाइक PM 2.5 दे कैन कन्वर्ट टू ए कोर्सा पार्टिकुलेट। सो दैट इज अ इम्पोर्टेंट फैक्टर। अगर मॉइस्चर ज्यादा हो तो आपको शायद ज्यादा लार्जर पार्टिकुलेट एटमॉस्फेयर में मिल सकता है आपको। और ये जो हम लोग सैटेलाइट वाले जो काम करते हैं, जैसे बेसिकली हम लोग ऑप्टिकल प्रॉपर्टी यूज करते हैं, उसमें मॉइस्चर का एक ज्यादा इंपॉर्टेंट रोल है, क्योंकि अगर एरोसॉल का साइज बड़े हो जाए तो वो काफी सारे क्वेश्चन खड़े करते हैं जो कि कैसे
ये प्रश्न इसलिए रखा मैंने कि रिवाइस में रिमेडी में इसकी जरूरत पड़ेगी, चूंकि ये एलुवियल प्लेन है, लो लैंड।
यस, तो ये पॉइंट था सर, जो अगर हम लोग जब मानसून पीरियड में बात करते हैं, जब रेनफॉल काफी अच्छा खासा रेनफॉल है, तो हमें इतना पोल्यूशन नहीं मिलता है। लेकिन जब समर के टाइम पे मॉइस्चर बहुत कम है, तो ड्यू टू दिस मतलब ज्यादा जो डस्ट हमें आसमान में आता है। और ये एक चीज और भी फैक्टर है, जो पेव्ड रोड नेटवर्क हमारे पूरे उत्तर भारत में इतना अच्छा नहीं है सर। तो जब भी गाड़ी जब ये टूटा फूटा रोड में जाता है, तो पोल्यूशन व डस्ट पार्टिकल इजीली सस्पेंड होता है एटमोस्फियर में, कंपेयर टू द साउदर्न इंडिया और एनी अदर रीजन जहां पे ज्यादा रेनफॉल हो, रोड नेटवर्क अच्छा हो, तो वहां पे उतना सस्पेंशन, उतना डस्ट पार्टिकल एटमोस्फियर में नहीं आएगा, कंपेयर टू दिस रीजन जहां पे रोड नेटवर्क इतना प्रॉपर नहीं है। तो ऑफ कोर्स ह्यूमिडिटी जो पोल्यूशन का लोड को भी थोड़ा बढ़ाता है। रेनफॉल जो जैसे यूरोपियन कंट्रीज दे कीप ऑन हैविंग मोर फ्रीक्वेंट रेनफॉल, जिससे क्या होता है, आसमान काफी क्लीन हो जाता है, जो हमारे यहाँ पे नहीं होता है। वी डू नॉट गेट एडुकेट रेनफॉल ड्यूरिंग समर और विंटर पीरियड, सो आसमान में वो पोल्यूशन स्टैग्नेंट हो जाता है सर।
बहुत बहुत बधाई, धन्यवाद। मैं बनारस आते रहता हूँ, हर एक 2-3 महीने पर मिलूंगा आपसे, है ना?
बिल्कुल सर, माय
और
प्रिविलेज।
मैं काफी इंटरेस्टेड है। मित्रों, 2 मिनट समय आपसे लेता हूँ। आप हमारे यंग जनरेशन हो, ऊर्जा प्राप्त करके आगे भी बढ़ सकता हूँ।
सीएम हाउस से मेरा कॉल आया है, मुझे जाना है, इसलिए मैं वोट ऑफ थैंक्स करते हैं। प्लीज एक्सक्यूज मी सर। So I would like to announce the next topic for our next lecture, the coming month, ensuing month. The topic will be about legacy solid waste management by our honorable guest speaker will be Engineer Arun Kumar. He is a superintending engineer. He is a superintending engineer from the Municipal Corporation of Delhi. And we will be having this lecture on 25th of January 2023 at 3 p.m. So this is going to be the next month's topic. So with this, I would like to take this opportunity to thank our honorable guest speaker, today's honorable guest speaker, Professor Tirthankar Banerjee from Banaras Hindu University. Sir, we were enlightened by your very informative lecture. Rather, we would like to hear you once again. So we'll approach you for a talk on similar topic, somewhat related to the similar topic. So we are looking forward to hear you once again, sir. Thank you for accepting our request and delivering such a wonderful, informative lecture. I thank you on behalf of our honorable chairman, Bihar State Pollution Control Board. Actually, he has left just now. He had some other pressing engagement now. So he has conveyed his thanks to you, sir. So, and also on behalf of my colleagues who are seated here with me, and also on behalf of the few guests who have joined us virtually also, I thank you so much for accepting this offer, sir, and for enlightening us. Also, I take this opportunity to thank Professor S.N. Tripathi, sir, who has taken his time to join us and to encourage us. Sir, thank you so much. I think sir has got disconnected, it seems. He is traveling now, so he could not stay connected. Also, I take this opportunity to thank all the guests and all the participants who have joined this lecture today, and looking forward to see you all once again next month on 25th of January. Thank you so much. Happy New Year.
Happy New Year. Happy New Year.
Thank you so much, sir.
Thank you. Thank you. খুব ভালো থেকো।
Thank you.